Hello, today I'll be presenting my work on text analysis and document retrieval using Python to process PDF and implement various information retrieval techniques. Question 1. I created a function to read PDF files from a specific directory. Using the pypdf library, I retrieve text from first 10 PDF documents. This function accumulates the text content and stores it alongside the corresponding file's name. Here are the function. Now let's run the code and check the output. Here are the outputs for question 1, displaying the content of all PDF files, a total of 10 PDF files. Question 2, I then move to compute the term frequency inverse document frequency TF-IDF scores. Using TF-IDF vectorizer from scikit-learn, I process this tag while removing stop words and stemming the words via an LTK. These are the function of compute TF-IDF scores. And these are the pre-process function where do the stop words removal and then stemming. Now let's run this code and see the output. The output shown the TF-IDF score for terms in each PDF files. So I have sorted these TF-IDF scores in descending orders and only output the top 20. So this for P1, P2, P3, P4, P5, and so on until P10. Question 3. For ranking documents based on a query, I again utilize cosine similarity, computing the similarity between query vector and document vectors. These are the functions for rank the documents. Let's test our code with the first query, which is digital twin is related to generative AI. Here are the output. P8 ranking first because it has the highest cosine similarity, followed by P1 and P10. Now for the second query, machine learning and 5G technology. Let's run this. P7 ranking first, followed by P9 and P10. And finally, the last query to be tested, quantum AI can be supported by IoT. So this is the ranking for the query. P2 first, followed by P1 and P10. Question 4. I tackled the computation of frequent term sets given a user query. This involves counting term occurrences across documents and filtering combinations that met a user-defined frequency threshold. So these are the functions that will do the frequent term set combination. And this function will search for the frequent term set. Let's try with the first query first, which is the digital twin is related to generative AI. These are the results of the query, where we see the term generative AI and digital are included, and it should exist at least in 2 documents. So for other term, it may not exist more than 2 documents. In frequent term set, we got generative and digital in document P5 and P7. This is because there are intersection of P5 and P7 for both terms. Next, the second query, machine learning and 5G technology. These are the output. Finally, let's test with the third queries, which is quantum AI can be supported by IoT. Here are the output. Question 5. Finally, I computed the precision of my retrieval system. Given the rank of documents produced and identified relevant documents, I evaluated performance based on the proportion of relevant documents retrieved. This is the function to compute the precision of the document. Now let's test our code with the first query, which is digital twin is related to generative AI. Okay, let's go to tree. So precision at position 3 is equal to 1. For the second query, machine learning and 5G technology. Precision at position 3 equal to 1. Last but not least, quantum AI can be supported by IoT. Precision at position 3 also 1. But let's try to increase the gain. For example, 15. And run this again. We got 0.7. Basically, based on my hypothesis, when the value of k increase, then the value of precision at position k will decrease.